In this video, we're going to talk about rational exponents. And rational exponents means that the exponents are fractions. You're used to seeing exponents as whole numbers. Now our exponents are going to be fractions. And the way to simplify these rational exponent expressions is by using radicals. So that means we're going to have to use these symbols to simplify them, okay? So how do I do that? Well, I write my radical symbol. This number here, which is called the base, that number goes inside the radical. The numerator of this fraction is always your exponent. So the exponent for 16 is a 1. And we know that when the exponent is 1, we don't write it. And then the denominator of this fraction is a 4. That denominator is your index right there. So you have translated this rational exponent expression into a radical expression which we can solve or we can simplify. What is the fourth root of 16? What this is asking you is, what number do I multiply by itself 4 times and get 16? Well, the number is 2. How do I know? Because 2 times 2 times 2 times 2 is 16. And there I have simplified the rational exponent expression. Let's go to example 2. For example 2, I have 8 to the 2/3 power. So the first thing you do is you write your radical. Second thing, you take your base, you write it inside the radical. Third thing is your numerator. Remember, that's the exponent. So I'm going to write the exponent here. And then the denominator is the root. Now, to simplify this, there are 2 ways. I'm going to show you this first method, and then I'm going to show you the second method, which is the method I prefer. For this first method, we have to do 8 squared, right? So I would have to write the cube root of 8 squared, which is 64. Yes? Okay. And now I can simplify the cube root of 64. I ask, what number do I multiply by itself 3 times to get 64, and that number is, oops, I'm sorry, I should have written that, and that number is 4. Because 4 times 4 times 4 is 64. So I've simplified this. This is equal to 4. This one is equal to 2. Okay, now let's do this, the second method here. That's method A. Method B is writing the radicand like we do. The base is inside. The exponent of 2, instead of writing it in here, I can raise the whole radical to the second power like that. And it's equivalent. And I'm going to show you that it is. And then the denominator, that's always your index. So the only difference between these 2 methods is that in the first method, the exponent, I wrote it inside of the radical. In the second method, I wrote the exponent outside of the radical, raising the radical to the second power. And I like this method better because then I simplify what's inside the parentheses. We use order of operations, parentheses first, and then exponents, right? PEMDAS. So doing what's inside the parentheses first gives you a result of 2, right? Because the cubed root of 8 is 2. And then I raise that to the second power, and that gives you 4. And you see, you still get the same result as with the first method. Let's do example 3. For example 3, I'm going to write the radical. Inside the radical, I'm going to write negative 125. The numerator is a 2. That means I'm going to raise the whole thing to the second power. The denominator is a 3. That means this is a cube root. There you have it. Now I can simplify this. I know what the cube root of negative 125 is. This inside of the parentheses gives you negative 5. And then I raise the negative 5 to the second power, and that will give you positive 25. So this simplifies to positive 25. Okay? Now if I use the other method where I write the radical, I write the radicand, I raise this 25. I raise this to the second power, and use the cube root, this is more difficult because then I have to multiply 125 times 125. And that's going to give you a really big number. It's going to give you the cube root of positive 15,625. Positive because negative times negative will be positive. And then the cube root of this is 25. So see, this is more difficult to work with because the numbers are way too big, okay? I'm sure with a calculator, well, this would be easy. So I prefer this method where you raise the whole radical to the exponent and it's easier to solve by hand. I'm going to give you 3 exercises for you to work on. I want you to hit pause and then come back for the answers. Here are the 3 problems. Go ahead and work on them. Hit pause and come back. Here are the answers. For number 1, I wrote 64 underneath the radical. The root is the 3, the denominator. The exponent of 1, since it's a 1, I don't write it. And the cubic root of 64 is 4. Done. Second example, 4 underneath the radical. The denominator is a 2. The denominator is your index, but remember when this index is square, we don't write it. So that's why you don't see it here. And then the exponent is 5. And then you solve the parentheses first. Square root of 4 is 2, and then raise it to the 5th power. That gives you 32. For the third example, write the radical. The base is 625 inside the radical. The numerator is what you're going to raise the radical to the 3rd power. The denominator is your root. Solve inside the parentheses first. The 4th root of 625 is 5, because 5 times 5 times 5 times 5 is 625. Then you raise that to the 3rd power and you get 125. I hope you got the right answers. If you didn't, go back and try them again. I'll see you in the next video.